Hi friends, welcome back to the next session. In this session, let us look in detail what the linked list is. A linked list consists of nodes. So as seen in the figure, we have a node and the nodes are linked together. So the node consists of two parts. The first part where we have data, and the second part we have address where the next node is situated. The main reason for using the linked list is we don't have sufficient contiguous memory whenever we require. In that case, wherever memory is available, we should be able to make use of it. So for efficient usage of the memory, whatever chunk of memory is available, we should be able to work on it. So what we can do now is we should just look for memory just sufficient to store one node. One node means it should have sufficient contiguous memory to store the data, followed by another contiguous memory, which is sufficient to store the address where the next node is situated. So if we get a contiguous block of memory which is sufficient to store these two information, one the data and one the address. So that's enough for storing one data, one node. So we have the node where each node will contain one data, and then we have address that's in our graphical way can say the pointer to where the next node is, or in our memory allocation or memory usage language also we make use of the pointers to represent where the next node is situated. Yes, it is still a linear structure. You can see that the whole thing is a linear one, and it is dynamic. So currently we have four nodes. That means we are now able to store four data. If we want to store five data, we just add one more node maybe after this end, and then instead of calling a null here, we write the address of the next node wherever it is situated, and the on that last node we just write a null at its address, and we start calling that last node as the tail, the first node as the head. So we have a concept of calling the first node in the linked list as a head and the last node in the linked list as a tail. So this is the what a linked list is. So now looking at the advantages of the linked list, yes, we can efficiently insert any new data wherever we want. It can be in the beginning, it can be in the middle, or it can be at the end. So just as an example, we want to insert a new node in somewhere on the way in the linked list. Say at the third position, we want to add this new node. So what we can do is just create a new node and add the new data to that new node, and then this the next, which was supposed to be null when we initiated this new node, instead of null, we just write address of this particular node. So we create a connection to this node, to this node, and from this node, earlier it was the next node was this node. Instead of calling this as the next node, we call this as the next node. That means the new node created, if we call address of that here, then what happens is after 91 it goes to this new node. So now after inserting a new node, the data we read is 43, 91, 15, 23, and 55. And because it's null here, that's the end of it. So we'll have 5 elements in the array, 5 elements in the list, sorry, not the array. Before inserting this, there were only 4 elements, 43, 91, 23, and 55. So on the same ground, if we want to delete any element, say we had a list of 4 elements, 5, 10, 15, and 20, and if we want to delete this element or this delete this element, then we just delete this node. But make sure that before deleting this node, what we do is just next of this previous node should be made same as next of the current node, whichever node we are deleting. The next of that was 20, so that is written here. So whatever next was there in this node, it is copied here, and this node gets deleted. So we now have a connection from this node to this node. So now we are free to delete this node. So it is very efficient to insert any new node or delete any node in the list. So we are witnessing that the size of the data is no more static, it is dynamic. So in the previous case, when we were inserting, before insertion there were 4 data, after insertion there are 5 data. So the size of the list is changing. Same way, after deletion, the size of the list has reduced. So it is no more static. Now we are working with dynamism. So you don't have to define the size of the list we want to use in the compilation time. So we just create as and when a new node is required. We can just create a new node and then make appropriate connections, or we can delete any available node by making appropriate connections. So the size of the list is no more fixed. It can keep varying as and when required. So that means this whole activity we are doing at the runtime, not at the compilation time. So the size of the list now is dynamic. It is no more static. So that's the advantage, which was a problem with arrays where it was static, because the size of the array has to be defined before compilation. So the size was defined at the compilation time, and during runtime it was not possible to change, hence it was static. And as of course, because for any node, what we require is one contiguous memory sufficient to store one node. So you don't have to have contiguous memory for all n data at one place, just sufficient to store one node. If you have a contiguous memory, that is sufficient. Chunks of such contiguous memory, n such chunks, can be used by interconnecting them appropriately to store n data. So the no more need of contiguous memory is required once we start working with linked list. And looking at the types of linked list, it can be a single linked list where the link is only in one direction. That means we start from the head reach the first node, then using the next, we go to the second node, using the next, we go to third node, using next, we go to fourth node, and so on, till we reach a null at the address. We can keep moving from left to right. So this is only unidirectional. So if we start from the head and we can go on moving till we reach the tail. Now we have another type of linked list which is doubly linked, so that both direction we can move. So we can move from the left to right using this rightward arrows. So we have a new structure for the node. So the now in this case node contains one data location and two address locations. One address shows where the next node is located, and the address, another address shows where the previous node is located. So we have two address fields, one for the next node and one for the previous node, and one for the data. So totally three components are there when we are working with a doubly linked list. And we have one more type, which is a circular linked list, which can be either singly linked list or doubly linked list. Only difference here is the head and tail are the same. So instead of writing a null here, if we can write the address of where the head node is, then it becomes a circular one. So same way, we can make use of a circular for the doubly linked list. That means from data 1 we go to data 2, from data 2 we go to data 3. Then using this forward link we can come back to data 1, or from data 3 we can go back to data 2, then back to data 1. Then using this loop we can get back to data 3, and so on. So this two types of circular linked list we can have using a single linked list or using double linked list. We can create a circular. So this null if represents the first node, and if this null represents the last node, then it becomes this doubly linked circular list. So the single linked list, double linked list are used when we don't want to restrict the size of the linked list. But if we want to have a limited number of nodes, then it is better to make use of circular linked list. And with limited number of nodes, we can keep on moving round and round, and can make use of a limited number of nodes for a bigger activity, provided we know that any given time the number of data we want to store is not more than this size of the linked list. The number of nodes we have, if it is more than the number of data we want to store at any time, then of course this will be much useful. Circular linked list will be useful. So more details about the single linked list, its operation, double linked list, its operation, circular linked list operations, and all, we look in the future sessions. So keep watching. If you find the sessions useful, please don't forget to like and hit the subscribe button, and please inform to your friends to watch and like and subscribe. Thank you.